Okay, so can I draw your attention to the board for just a second? This was a question which came up, which is a perfectly good question. So what we can do here is we can use our SOHCAHTOA, like we were using before. So let's first of all start by labelling up the sides. This is the angle which we've been given, so we need to label our sides up in relation to that angle. What would the 7 correspond to? What would the side with 7 centimetres correspond to? It's the hypotenuse, good. What would this side be called? The adjacent. So actually in this case, what aren't we interested in? Yeah, we're interested in the cosine, but we're not interested in the opposite side, which means that when we write our 3 triangles out, we can't have a triangle, formula triangle, with the opposite in because we're not interested in it. So you see here, that's got an opposite in, so that's out. That's got an opposite in, so that's out. This is the formula triangle that we need to use. Okay? So let's think. Let's think. What are we interested in? The angle, right? So we need to find the angle. So which of these letters corresponds to the angle? The C, the A, or the H? It's the C, right? The A stands for the adjacent. The H stands for the hypotenuse, so it must be C. So if we're interested in C, how are we going to combine together the A and the H? Good, well done. A divided by H. Now we fill in what we know. Now remember, what is C short for? Cosine. And it's always cosine of the angle. In this case, our angle is x. Okay, what's our A? Good. And what's our hypotenuse? 7. Good. Now how could we find x? Okay, good. So this is the idea of an inverse function in this case. What we're literally saying is that if we take the cosine of an angle, that's a function. Okay? It's basically saying your input is your angle, then you're applying the cosine function to it. Now don't worry too much about what functions are at this stage. We have briefly met them with transformations of graphs, okay? But we will meet the cosine function again in just after Christmas, okay? But for the moment, just think of this as an operation which I apply to the angle. Now, there should always be a way, or there's usually a way, to undo that operation. And we call that an inverse. Think about it. If I multiply by 2, what's the reverse of that? Dividing by 2. If I subtract 10, what's the opposite of that? Adding 10, okay? And it's the same kind of idea here. If I'm applying an operation to my angle, there should be an inverse operation that undoes that, okay? And in general, the inverse operation for cos would be to the power of -1. Why do you think we put a -1 there if it's an inverse operation? Doesn't mean 1 over cosine in this case because it's an inverse function. It's an inverse function. But you're right. Usually if I have, for example, 2 to the power of -1, that would mean the inverse of 2. Okay? Yeah, 1 over cosine is something slightly different here. This is something which undoes cosine. Okay? So if I want x, I would just simply apply the inverse function on both sides. Well, are you happy that if I do the inverse function of a function, what should I be left with? I should just be left with, in this case, what I started with, yeah? If I subtract 2, but then immediately add 2, I should be left with what I started with. So if I apply my function to x, then I apply the inverse function to x, I should be left with x, okay? Okay, fine. But if I apply it on both sides, then I've also got to take the cosine inverse of 3/7, okay? And you're right, Ahmed, how you get the cosine inverse is it's just shift, which is in the top left of your calculator, then press cos, and then you type your 3/7 equals, and then that's your answer. Okay? Yes, of course. Okay, so your answer is 64.6 degrees there. Are there any questions about that?